depth of burial for bonding conductors is regulated by the National Electrical Code, specifically Article 680.26, which pertains to swimming pools, fountains, and similar installations. When installing an 8-solid bonding conductor for an in-ground pool, the required burial depth differs depending on whether the conductor is installed directly in the earth or within a PVC conduit. Without PVC conduit, the bonding conductor must be buried at least 18 inches below grade, according to Section 680.26c of the National Electrical Code. This depth ensures that the conductor is adequately protected from physical damage and corrosion. When the bonding conductor is run inside a PVC conduit, the National Electrical Code Section 680.26 does not specifically state the burial depth. In such cases, it is typically recommended to follow Table 300.5 of the National Electrical Code, which provides minimum cover requirements for underground installations. Table 300.5 generally requires a minimum burial depth of 24 inches for PVC conduits containing electrical conductors. This greater depth is intended to provide enhanced protection for the conduit and the conductors within, especially in areas subject to heavy traffic or potential excavation. Now, addressing the sealing of connections, Section 680.26 of the National Electrical Code does not explicitly mandate the sealing of bonding conductor connections. However, sealing connections is a recommended practice to prevent moisture infiltration and corrosion. Moisture can lead to the deterioration of the connection, increasing resistance and potentially compromising the effectiveness of the bonding system. Corrosion can also weaken the connection, making it unreliable over time. Although Section 680.26 does not specifically require sealing, Table 300.5, which applies to all underground installations, including bonding conductors, necessitates the use of approved moisture-resistant materials for connections. These materials can include sealing compounds or tapes designed to protect the connection from moisture and environmental factors. Using these materials helps ensure a reliable, long-lasting connection that maintains its integrity over the life of the installation. For in-ground pools without grids, there are additional bonding requirements to consider. While a bonding grid is not mandatory for pools without grids, all metal components within 10 feet of the pool must be bonded together. This includes the pool ladder, the filter pump, and any other metal equipment or structures in the vicinity. The purpose of this bonding is to create an equipotential plane, minimizing voltage gradients in the pool area and reducing the risk of electric shock. The bonding conductor must be sized appropriately based on the maximum fault current available at the service. Table 680.26d of the National Electrical Code provides guidance on selecting the correct conductor size for bonding based on the amperage rating of the overcurrent protection device in the circuit. Proper sizing of the bonding conductor is crucial to ensure that it can safely carry fault current back to the source, facilitating the operation of the overcurrent protection device and clearing the fault. When fiber optic lighting is used in the pool, it must be specifically listed for underwater use. Fiber optic lighting systems consist of two main components: the light source and the fiber optic cable. The light source is typically located remotely, away from the pool, while the fiber optic cable carries the light to the underwater fixture. The underwater fixture must be designed and listed for submersion, meaning it has been tested and certified to withstand the conditions of being underwater, including exposure to chemicals and water pressure. The installation of fiber optic lighting must be done in accordance with the manufacturer's instructions. These instructions provide specific details on how to properly install the lighting system, including the correct wiring methods, grounding requirements, and mounting procedures. Following the manufacturer's instructions is essential to ensure the safety and proper functioning of the lighting system. It's important to note that the specific requirements for bonding and grounding can vary depending on local codes and regulations. Always consult with a qualified electrical inspector or engineer to ensure that your installation complies with all applicable requirements. They can provide guidance on the specific requirements for your location and help ensure that your installation is safe and code compliant. Firstly, understanding the terminology is critical. Bonding refers to the permanent joining of metallic parts to form an electrically conductive path that ensures electrical continuity and the capacity to safely conduct any fault current likely to be imposed on it. Grounding, on the other hand, refers to connecting the electrical system to the earth, providing a path for fault current to return to the source and trip the overcurrent protection device, such as a circuit breaker or fuse. These two concepts are essential for electrical safety in swimming pool installations. Secondly, the purpose of bonding and grounding in swimming pools is to minimize the risk of electric shock. By bonding all metal parts together, an equipotential plane is created, which means that all metal surfaces are at the same electrical potential. This reduces the likelihood of a voltage difference between different metal parts, which could cause a shock if someone touches them simultaneously. Grounding provides a path for fault current to return to the source, causing the overcurrent protection device to trip and to energize the circuit in the event of a fault. Thirdly, let's delve deeper into the bonding requirements for in-ground pools. As mentioned earlier, all metal parts within 10 feet of the pool must be bonded together. This includes the pool ladder, the pump, the filter, any metal fencing, and any other metal equipment or structures in the vicinity. The bonding conductor, typically an 8-solid copper wire, must be connected to each of these metal parts using approved bonding connectors. These connectors must be suitable for direct burial and must be corrosion resistant. Fourthly, the bonding conductor must be run continuously and without splices. If a splice is necessary, it must be made using an approved splicing method that ensures a permanent and reliable connection. The bonding conductor must be connected to the pool's reinforcing steel, if present, at multiple points. This helps to create a more effective equipotential plane and further reduce the risk of electric shock. Fifthly, let's consider the grounding requirements for in-ground pools. The pool's electrical equipment, such as the pump and the filter, must be grounded to the electrical system's grounding electrode system. This is typically done by connecting a grounding conductor from the equipment grounding terminal to the grounding electrode conductor, which is connected to the grounding electrode. The grounding electrode can be a ground rod, a ground plate, or the metal underground water pipe. Sixthly, it is important to ensure that all electrical equipment used in the pool area is listed for use in wet locations. This means that the equipment has been tested and certified to withstand the conditions of being exposed to moisture and water. Using equipment that is not listed for wet locations can be dangerous and can increase the risk of electric shock. Seventhly, special attention should be paid to the installation of underwater lighting. Underwater lighting fixtures must be listed for underwater use and must be installed in accordance with the manufacturer's instructions. The lighting fixtures must be properly grounded and bonded to the pool's bonding system. The wiring to the lighting fixtures must be run in approved conduit and must be protected from physical damage. Eighthly, it is crucial to maintain the pool's bonding and grounding system. Regularly inspect the bonding and grounding connections to ensure that they are tight and corrosion-free. If any connections are found to be loose or corroded, they should be repaired or replaced immediately. Periodically test the bonding and grounding system to ensure that it is functioning properly. Ninthly, remember that the National Electrical Code is a minimum standard. Local codes and regulations may have additional requirements. Always consult with a qualified electrical inspector or engineer to ensure that your installation complies with all applicable requirements. They can provide guidance on the specific requirements for your location and help ensure that your installation is safe and code compliant. Tenthly, and finally, safety should always be the top priority when working with electricity. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electric shock. Let's discuss some specific scenarios and how the bonding and grounding requirements apply. Imagine a pool with a metal fence surrounding it. The metal fence must be bonded to the pool's bonding system. This ensures that the fence is at the same electrical potential as the other metal parts around the pool, reducing the risk of electric shock if someone touches the fence and another metal part simultaneously. Now consider a pool with a gas heater. The gas heater must be bonded to the pool's bonding system, and it must also be grounded to the electrical system's grounding electrode system. This ensures that the heater is properly protected from electrical faults and that it is at the same electrical potential as the other metal parts around the pool. Let's examine a pool with a slide. The metal supports of the slide must be bonded to the pool's bonding system. This ensures that the slide is at the same electrical potential as the other metal parts around the pool, reducing the risk of electric shock if someone touches the slide and another metal part simultaneously. In the event that the pool has an automatic pool cover, the metal components of the pool cover mechanism must be bonded to the pool's bonding system. This ensures that the pool cover is at the same electrical potential as the other metal parts around the pool, reducing the risk of electric shock if someone touches the pool cover and another metal part simultaneously. Remember, the goal of bonding and grounding is to create a safe environment for swimmers. By following the requirements of the National Electrical Code and consulting with qualified professionals, you can help ensure that your pool is electrically safe. Let's reiterate the importance of using approved materials and methods for bonding and grounding connections. The connectors used to connect the bonding conductor to the metal parts must be listed for direct burial and must be corrosion resistant. These connectors are typically made of copper or bronze and are designed to withstand the harsh conditions of being buried in the ground. The splicing methods used to join the bonding conductor must be approved and must ensure a permanent and reliable connection. Approved splicing methods include using compression connectors or exothermic welding. Avoid using wire nuts or other unapproved splicing methods, as these can be unreliable and can increase the risk of electrical faults. It's also crucial to protect the bonding and grounding conductors from physical damage. The conductors should be run in a way that minimizes the risk of being cut, crushed, or otherwise damaged. If the conductors are exposed to physical damage, they should be protected by conduit or other suitable means. Regularly inspect the conductors for any signs of damage and repair or replace them as needed. In addition to the bonding and grounding requirements, there are other electrical safety considerations to keep in mind when installing or maintaining a swimming pool. Always disconnect the power to the pool equipment before working on it. Use a voltage tester to verify that the power is off before touching any wires or connections. Keep electrical equipment away from water. Do not place electrical equipment near the pool where it could get wet or be splashed with water. Use ground fault circuit interrupters, or GFCI protection for all electrical circuits serving the pool area. A GFCI is a device that detects ground faults and quickly shuts off the power to the circuit, preventing electric shock. Install signage warning people to stay away from electrical equipment near the pool. This can help prevent accidental contact with electrical equipment and reduce the risk of electric shock. Educate swimmers about electrical safety. Teach them to stay away from electrical equipment and to report any electrical hazards to a responsible adult. By following these additional electrical safety precautions, you can further reduce the risk of electric shock and create a safer swimming environment. Let's delve into the specific requirements for fiber optic lighting in more detail. As mentioned earlier, fiber optic lighting systems consist of two main components: the light source and the fiber optic cable. The light source is typically located remotely away from the pool, while the fiber optic cable carries the light to the underwater fixture. The underwater fixture must be designed and listed for submersion, meaning it has been tested and certified to withstand the conditions of being underwater, including exposure to chemicals and water pressure. The fiber optic cable itself is non-conductive, so it does not pose an electrical shock hazard. However, the light source and the underwater fixture must be properly grounded and bonded to the pool's bonding system. The light source must be installed in a dry location and must be protected from moisture and water. The wiring to the light source must be run in approved conduit and must be protected from physical damage. The underwater fixture must be installed in accordance with the manufacturer's instructions. The fixture must be properly sealed to prevent water from entering the fixture and causing electrical problems. The fixture must be securely mounted to prevent it from coming loose and floating in the pool. When installing fiber optic lighting, it is important to use only components that are specifically designed and listed for use in swimming pools. Do not use components that are not listed for this purpose, as they may not be safe and could increase the risk of electrical shock. It's also important to follow the manufacturer's instructions carefully when installing fiber optic lighting. These instructions provide specific details on how to properly install the lighting system, including the correct wiring methods, grounding requirements, and mounting procedures. If you are not comfortable working with electricity, hire a qualified electrician to install the fiber optic lighting system. They will have the knowledge and experience to install the system safely and correctly. Remember, electrical safety is paramount when working with swimming pools. By following the requirements of the National Electrical Code and consulting with qualified professionals, you can help ensure that your pool is electrically safe and that swimmers can enjoy the pool without the risk of electric shock. It's worth noting that the National Electrical Code is updated every 3 years, so it's important to stay current with the latest requirements. The latest edition of the National Electrical Code is available from the National Fire Protection Association. You can also find information about the National Electrical Code on the internet. In addition to the National Electrical Code, there may be local codes and regulations that apply to swimming pool installations. These local codes and regulations may be more stringent than the National Electrical Code, so it's important to check with your local building department to ensure that your installation complies with all applicable requirements. Finally, remember that electrical safety is a shared responsibility. Pool owners, pool operators, and electricians all have a role to play in ensuring that swimming pools are electrically safe. By working together, we can help prevent electrical accidents and protect swimmers from electric shock.